Hi student, now we're going to look at part 2 of geometric progression. Now here, a series is the sum of terms of a sequence. For example, 2 plus 4 plus 8 plus 16 plus 32. It is possible to calculate the value of the sum of the series. So this value is usually called as n, where n is the number of the terms in the sum. So for example, we have the first one that you can see here, S5. S5 is equals to 2 plus 4 plus 8 plus 16 plus 32 equals to 62. So S5 means I have the sum of the first 5 sequence. Okay, the first term, second term, third term, fourth term, and fifth term. There's altogether 5 terms here. Each of them come with a value, and the total is 62. Now here, this is the formula, sum to n term of an geometric progression formula. Prove that the sum of the first n term of a geometric progression is given by Sn equals to a times bracket a minus r to the power of n close bracket over 1 minus r. Now to prove this, so as what you already know, n term is equals to ar to the power of n minus 1. So if I'm looking for Sn, I will have a plus ar squared plus ar cubed plus dot 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 plus ar to the power of n minus 2 plus ar to the power of n minus 1. Now this is how the proving works. Now I'm going to get another sequence that is going to multiply by r. So you have r as n. So because of the r over here, the first term will start from ar instead of a. So you have ar plus ar squared plus ar cubed plus ar power 4 plus dot 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 plus ar to the power of n minus 1 plus ar to the power of n. So if you were to use the first sequence minus the second sequence, you get 1 minus r Sn times Sn. Then the same thing you can do cancelling. Now on your right hand side you get a minus ar to the power of n. Now when we rearrange this thing, you get Sn equals to a times 1 minus r to the power of n over 1 minus r. Well, by the way, this is the proving part. So if in the case that you're wondering how this formula comes from, it comes from this proving. Okay, but for your level now, what we need to do is we have to focus more on the application part. Yeah. Now, geometric progression formulae, n term, you have ar to the power of n minus 1. Sum to n term, we have two formulas here. Sn equals to a times 1 minus r to the power of n over 1 minus r, or Sn equals to a times r to the power of n minus 1 divided by r minus 1. Okay, how come there's two formula here? Now, either formula can be used when it comes to solving your questions, but it will be easier for us to use the first equation, the first formula, which is this one, when your r lies in between -1 and 1. Use this second formula when your r is greater than 1. Okay, this formula can be found on your textbook page 259. Now let's check the work example now. Find the sum of the first 10 terms of the geometric series 2 plus 6 plus 8 plus 54 plus dot dot dot. Now from what you can see, my first term is equals to 2, my r is equals to 3. So I believe the last video you already learned how to look for common ratio. You use u2 divided by u1. The second term divided by first term. And since you and here the n would be 10 terms. It's being asked in this question. So now in order for you to look for the sum, which formula should we use? We use this one. Why? Because if you pay attention to what I said just now, when your r is greater than 1, we use the second formula. But here, instead of the second formula, they are actually using the first formula, which is the first formula. Huh. I thought you said we're not supposed to use the first or second. Again, either formula can be used. Yeah, either formula can be used. Let's see what will happen if I were to use the second formula. The second formula will gives you Sn equals to A. Your A is 2, so 2 bracket 3 to the power of 10 minus 1 over r minus 1. Your r is 3, so 3 minus 1. Okay, now if you key in these two things into calculator, you should be getting the same answer. Let's test out and see. Two times 1 minus 3 to the power of 10, close bracket, 1 minus 3. You get 59,048. What if I were to change this thing? You get the same answer as well. The reason why they're asking you to pick the formula earlier on is because when your r is in between -1 and 1, as if I were to use this formula, it will produce a positive answer. It will produce a positive working compared to the other one. Okay, now let's check on the next word example, 17. The second term of a geometric progression is 9 less than the first term. The sum of the second and third term is 30. Given that all the terms on the progression are positive, find the first term. Now, the second term of a geometric progression is 9 less than the first term. So here I have a minus ar equals to 9. And then they say the sum of the second term and third term is 30. So if I were to use my nth term for GP, you have AR plus AR squared. And when you add up these two, you get 30. Given that all the terms on the progressions are positive, find the first term. That means I need to look for my A here. So based on the first equation that you built here, you can take out the common factor, which is A. So the second equation, same as well, you can take out your A. Let them be equation 1 and equation 2. So now, from equation 1, you have A equals to 9 over 1 minus r. Okay, now substitute this into equation 2, you get 9 over 1 minus r times r plus r squared equals to 30. So for this denominator, move to the right hand side, and on your left hand side, you're left with 9 and also the bracket r plus r squared. These two things you can expand. The same thing goes to the right hand side as well. Once you've done expand, rearrange them, and before you proceed to factorize, see whether there's any common factor that you can take out to reduce the value to a much smaller values. So now for this part, you should be able to use a calculator to help you to do your factorization. Your r is equal to 203 and your r is equals to -5. So we have to eliminate the second answer. We have to reject this answer. Why do we have to reject this answer? Because they say all the terms on the progressions are positive. So if I were to if you see, if my a is a number, if I were to use a negative values for my common ratio, there might be a chance that I will be getting negative terms in my progression. So back to the question, they're asking us to find the first term. So what is my a? Sub my r equals to 2 over 3 back into this equation. We have a equals to 9 over 1 minus 2 over 3. You get an answer of a equals to 27.